Ciao friends! In this video we will see how the DAX engine optimizes the switch function. This could be very important because many reports use slicers to select a value that corresponds to the measure you want to display in a matrix or in a chart, for example. It's very important that the switch statement is optimized because we want to pay the price to compute only the selection we made and not the cost for all the other measures that we are not consuming. So we will see in this video how the engine optimizes the switch function. Remember, these optimizations we will see have been introduced in 2021. And previously, before 2021, switch was often the reason why reports were very, very slow. The situation improved a lot, but there are still cases where switch does not perform in an excellent way. Usually, we will see the storage engine is usually very well optimized, but the formula engine could be not fully optimized, producing not optimal performance, especially if you have big switch statements or particular conditions in your report and in your data model. So we will see several cases when it works, when it doesn't, and the takeaway should be not only to understand how to tune your code, we will see only a few cases, but more important, how to analyze the query plan to understand whether this optimization is working 100% or is working only at the storage engine level. Let's start with the demo. So I prepared several demos that are included in the file you can download from the article related to this video. And in this model, we have a report which will be similar in all the pages. The report has a list of measures that I want to select to be displayed in this matrix. So for example, if I click on margin, you see that the value displayed here is the value of the measure margin. If I click on total cost, I see the value of the total cost measure. If I click on sales amount, I see the value of the sales amount measure. So how did we implement this? First of all, the slicer is a list of names, which by the way are not sorted alphabetically. You see that margin is the second one. And in order to show this slicer, we created a table that we can see here. A table that has just 3 rows, but the table has 2 columns. One is index and is hidden, and one is visible, is called name. We show the name in the slicer, but it is sorted by the column index. So this way we can control the sort order of the names displayed in the slicer. How the selected name measure works. The selected name measure uses the selected value over the column options name, retrieves the string corresponding to the selection made in the slicer, and for each string we execute the corresponding measure. So this is a very, very common technique, and we are interested in looking at the performance, but especially at the query plan. What happens internally to the storage at the storage engine level and at the formula engine level, because the goal is not to see the difference in performance. This model is small and we don't have a lot of names in the slicer, but we wanted to keep it simple just to be able to analyze the details of what we see in the storage engine and the formula engine. So I enable the performance analyzer and I capture what happens to populate the matrix visual. So I copy this query and I paste this query in DAX Studio. If I execute the query in DAX Studio, I see that this is the result we obtain. We have for each brand the value of the selected main measure plus the information for the ground row total. And you see that the query generated by Power BI has a lot of details that we could remove just to simplify the query and having something easier to analyze. So I'm just gonna replace this filter with the definition of the 3 tags. I'm gonna remove the grand total, column and row. I don't need it. And I can remove all the other elements here, the defined variables, ordered by, I just want the minimum number of information to analyze. So if I execute this query, I have basically the same result beside the grand total, a smaller number of rows in the DAX code, and also I will have a simpler query plan to analyze. Now I enable the server timings to check what happens at the storage engine level, and I enable the query plan pane to see what happens in the logical and physical query plan. So I start with the server timings. I want to run this query again, now tracking what happens at the storage engine level. And at the storage engine level, you see that we have a simple query to retrieve the value, the number of rows selected in the options table for sales amount. Basically, the engine already knows that we are filtering sales amount in options name and uses this information to simplify the entire query plan. Indeed, you see that we are only consuming quantity and net price from the storage engine. What does it mean? If we take a look at the measure selected name, so selected name, this measure can be included in the definition, including also the dependent measures. So let's see what happens. Oh, I put this in the wrong place. So let's go back here. Let me repeat this operation. Define dependent measure. Here we go. So we have now in the DAX code, we have the measure selected name that, depending on the selection, consumes sales amount, and sales amount only uses net price, total cost, and total cost would use unit cost, and so on. Now, if we see that our only storage engine request only uses net price and not unit cost, we know that we are not executing the measures margin and total cost, because otherwise we would have seen the consumption at the storage engine level of the unit cost column. But what happens at the query plan level? If we take a look at the query plan level, we can see that in the logical query plan, we have a reference to net price. You can see this here, but you will not see unit price referenced anywhere. Now, the logical query plan is prepared before actually executing any calculation. So this means that the optimizer is aware of the selection made in this report and is removing all the branches at the formula engine level that are not requested. Same happens at the physical query plan level. Also, the physical query plan level, you will see that there is a single storage engine request retrieving 11 rows. Here is where we consume the value for quantity multiplied by net price grouped by brand. And this is also visible here. Actually, is not visible in a direct way, but you see that there is only a single storage engine request consumed here that produces 11 rows that we see in the result of the DAX query. So this is the optimal condition. And in the optimal condition, we used a measure. Let's go back to Power BI Desktop. We consumed a measure, selected name, that used the options name, which is the very same column we displayed in the slicer. This is the optimal condition. Now, let's see what could go wrong. And let's start with an example where we have exactly the same report, but this time we used a different measure, which is here, selected index. And selected index has the same business logic, but this time, instead of using the name of the column name of the table options, we use the column index. The number we use that to define a proper sort order. There could be reasons why you want to do that, right? And so we used 1, 2, 3 instead of writing the string. There could be many reasons why you want to do that. But let's see what happens now if we execute the code for this measure. So if I go back to my definition of the execution, instead of using options name, instead of using here selected name, I want to use a selected index. This is to highlight that I'm still selecting a value in the options name column, but I'm retrieving the value from another column. Let's add here selected index. So here I define the measure selected index, and the measure selected index is using options index and not options name. Okay, so let's start looking at the result. So the result will be identical. Oops, I have to not select anything in the query. So the result is identical to the result we have seen before, no differences. If we go at the storage engine level, we see a small difference. There are 3 storage engine queries instead of 2, but we have the list of the brands here. We have a query that is used to retrieve the selection of the options index column based on the filter made on options name. Now, we know that we have only one value for each name, but the formula engine doesn't know that, and also it has to query the model to check whether what is the number corresponding to the selection made for that particular name. The data could change in the model, so this is required. And then the calculation that actually retrieves the value from the storage engine is only consuming quantity and net price. We don't see unit price here, so we know that we are not consuming additional storage engine power, right? We're not consuming CPU cycles from the storage engine because we are not querying the model for other columns that are not included just in sales amount, which is our selection. Now let's see what happens at the query plan level. Now, as I said, in this case, we want to start from the logical query plan, because at the logical query plan level, you see that now we have net price, unit cost. We immediately see that the logical query plan is longer and also includes references to possible branches of execution, total cost and margin, that involve that calculation that also includes unit cost. And this is the logical query plan, but what about the physical query plan? Well, in the physical query plan, you can notice that there are many more rows. And a few of these rows actually try to consume a cache that returns 0 rows. Now, technically, this does not execute a real storage engine request, but just the presence of this branch in the physical query plan will produce a formula engine CPU consumption. Now, this is not really the case for this example. If I run this query, the query is so fast, the execution time is just a few milliseconds. But if you have a much bigger model with hundreds of thousands of measures nested each other in several switch statements, maybe with many values in the switch statement, not just 3 rows, then you might start to notice some difference. And my experience is that this simple change could make a difference between 100 milliseconds and 1 or 2 seconds for the same report. So it depends on the model, but in complex models, this could happen. So the lesson here is that the maximum optimization at the storage engine and at the formula engine level happens only when the switch statement is actually using the selected value over the same column where you applied a direct filter. If the filter is indirect, so I filter a column, but I read the value from another column of the same table, even though we know there is a one-to-one relationship in that table, it doesn't matter. The engine has to query the model, and this removes part of the optimization at the formula engine level. And so this is very important. But there are other cases. So another case I want to show, and now we go back to Power Desktop, is this one. You see that in this case, the measure slicer is not showing all the values. Why? Because we introduced a filter at the page level, where we said, okay, I want to see all the names but one. Usually this is a filter like I want to see all the names but blank. I don't want to I want to show the blank row in the slicer. And if you do this, what happens? Well, the slicer only shows 2 rows, but remember, we apply the filter at the page level. So because it is applied at the page level, it affects this slicer and this other matrix. Now, because we are selecting only one value in the slicer, what is important is that we only filter one measure. But from a conceptual point of view, in the filter context, we still have also the condition that says other than total cost we define in this area of the filter pane. So what happens in this case? Once again, we go in Performance Analyzer, we refresh everything, and we copy the query. We have to start from scratch because in this case, it's important to see the code generated by Power BI. So I go back to, let's create a new, let's use this one, it's easier. So I replace the query with this code, and you see that now the code for the filter is this. And this filter is applied to these summarized columns. So if I replace the filter with the complete predicate, I remove the part from summarized columns that I don't want to see the grand total. I use evaluate, and I do the same simplification of the code that we did previously for my code. So you see that this time it's only that the filter code is more complex, and the filter context, even though we applied a filter that says we want this to be in sales amount, we still have a not in total cost. And so it's something strange, but this is the way Power BI generates the filter. What could go wrong? Okay, let's see what happens. So first of all, if I run the query, you see that the storage engine level, nothing happened. We have a very similar result as we have seen before. We still use only net price, not unit cost, so we don't have additional overhead at the storage engine level. So far, so good. The result is still the correct result. We don't see different numbers. But let's take a look at the query plan level. Please pay attention. The measure I'm using now is selected name. And selected name is that measure. Let me restore the measure selected name. The measure that worked very well in the first example. So if I go here and I include define measure, oops, just in the right place here, you see that I'm filtering sales amount, options name. Options name is set to sales amount, and options name is the column I'm reading. So this is the ideal condition where it's possible for the formula engine to get the maximum performance improvement. But this time, we're not filtering a simple condition column equal to value. We have a more complex predicate with an AND, a NOT condition. And what happens at this point? Let's take a look at the query plan. So if I go to query plan level and I go at the logical query plan level, once again, you see unit cost and net price. So the unit cost is here again. And let's just execute the code another time, just to be sure that we are executing the code with the definition we have seen now. You see unit cost, net price, everything is here in the logical query plan, and in the physical query plan, same problem. So even though we are using selected value, using the column that is actually the column displayed in the visual, we are not getting the maximum performance improvement at the formula engine level. Why? Because the predicate is a more complex one that is merging two conditions, one in the filter pane of the page and one is obtained as the result of the slicer connected to the matrix. So if I go back to the Power BI desktop file, this is the problem. So I filter name at the page level, and then this slicer filters the name again. So the filters applied to the matrix are two. One comes from the slicer, one comes from the page. And this is the reason why we have seen that end condition in the DAX code. So in this particular example, a solution is, instead of applying the filter at the page level, we could obtain the same result by applying the filter, guess what, at the visual level. If I apply the filter at the visual level, so I apply the same filter at the visual level only for this visual, I don't apply the filter at the page level, so the matrix will only receive one filter. And so if I try to start recording now, refresh the visual, copy the value here, the query here, go back in DAX Studio and paste the code, you see that now the filter is simply a 3TAS options name. So the difference is that now we only filter options name, and guess what? This is the same identical query we have seen previously in the initial example, the optimal one. So this will execute the optimal code. And the only difference is that we don't have to, compose multiple filters into the same visual that could create a situation where the engine is not able to provide the maximum optimization. And so these are different cases where we have seen how Switch could work or is not working well. In a few cases, by looking at the logical and the physical query plan, we can understand whether there are conditions that are evaluated even though they don't produce any storage engine requests. And this could be important in very large models. So we have seen that Switch has many optimizations that can work wonderfully in the optimal conditions, but there are cases when, even though the storage engine is not affected by additional cost, the cost for the formula engine could be there. And in a simple model, we don't care, we don't see the problem, but in larger reports, in larger data models, in complex and nested measures, this could result in additional costs at the formula engine level that could damage the performance of your reports. Enjoy DAX!